FPV drones, which stands for first person view drones, have become a game changer in modern warfare, especially in the ongoing conflict in Ukraine. From the perspective of a software engineer and a data scientist, the use of these drones provides fascinating insights into how technology is reshaping the battlefield. Let's start with what makes FPV drones unique. Unlike traditional drones, FPV drones allow their operator to see exactly what the drone sees in real time using a live video feed. This makes them incredibly precise and versatile for tasks like reconnaissance, targeting, and even direct strikes. The pilot wears goggles or uses a screen to navigate the drone as though they are inside it, giving them unparalleled control and situational awareness. In Ukraine, FPV drones are being used for both offensive and defensive purposes. Small, agile, and often inexpensive, they have become tools for asymmetric warfare. Soldiers and resistance fighters can use them to scout enemy positions, guide artillery fire, or even deliver explosive payloads. The effectiveness of these drones lies not only in their hardware, but also in the software and data analytics that power them. From a software engineer's perspective, the real innovation is in the algorithms and control systems that make these drones so effective. The software must process real-time video, manage stable flight in challenging conditions, and allow for precise maneuvering, often in environments where communication signals are jammed or unreliable. Open source software has played a significant role here, as it allows engineers to quickly adapt and customize drones for battlefield needs. This open source nature has created a rapid innovation cycle, with developers continuously refining drone capabilities. But the real magic happens when you add data science into the mix. Data scientists are helping to optimize drone operations using machine learning and artificial intelligence. For example, drones can be equipped with computer vision algorithms to identify targets automatically, track movements, or even distinguish between civilians and combatants. Predictive analytics, powered by large datasets, allows strategists to anticipate enemy movements and deploy drones more effectively. One particularly fascinating use case is swarm technology, where multiple drones operate together in a coordinated fashion. By using algorithms inspired by nature, such as the way birds flock or bees swarm, these drones can communicate with each other and adapt to changing conditions on the fly. This kind of technology requires a deep understanding of networked systems, real-time communication, and machine learning. On the ground, engineers and data scientists are constantly gathering feedback from deployed drones to refine their models. Every flight generates valuable data: how long the drone can stay airborne, how it responds to interference, and even how the enemy reacts to its presence. This data is then fed back into simulations and training models to make future drones even more effective. FPV drones have also blurred the lines between civilian and military technology. Many of these drones are modified versions of consumer-grade models, repurposed for war. This raises important questions about ethics, accessibility, and the future of warfare. As these tools become more sophisticated, it's likely we'll see even greater integration of artificial intelligence and autonomous decision-making, areas where software engineers and data scientists will play pivotal roles. But there's another side to this story. The rise of FPV drones in conflicts like Ukraine also underscores the growing importance of cybersecurity. Drones are vulnerable to hacking and signal jamming, and ensuring they remain operational in contested environments requires robust encryption and fail-safe mechanisms. This is where the intersection of software engineering and data security becomes critical. In conclusion, FPV drones are not just transforming warfare, they're a testament to the power of technology when applied to the battlefield. They combine cutting-edge software, data science, and hardware to create tools that are cheap, effective, and adaptable. For software engineers and data scientists, these drones represent a new frontier of challenges and opportunities, blending innovation with real-world impact in ways we are just beginning to understand. If you found this topic intriguing, let us know in the comments what you'd like us to cover next. And don't forget to subscribe to keep learning.